Now we are going to look at two examples where we are going to evaluate the composition of two functions at a given point, but we're not given formulas for these functions. So in the first example, we are given a set of values for f and g, and from this we're supposed to be able to recover the value of f of g of 3 and g of f of 3. So hopefully we've got all the data that we need to do this. So I'll start here with f. Let's start with f of g of 3. How would we calculate this? Well, this is actually pretty easy to do. What we need is we need g of 3. Okay, that's the first thing that acts on 3. We have to calculate g of 3. G of 3. So x, when x is 3, g of 3, this is g of 3, is going to be 2. So I can just replace g of 3 by 2. Okay, so in other words, you remember this little diagram. We send 3 into f, like that. I draw it like this. We send 3 into g. What comes out of it is g of 3, and then we send g of 3 into f, and what's going to come out of it is f of g of 3. Now g of 3 is equal to 2, so what we want to calculate here is f of 2. Okay, f of 2. So then I look, when the input is 2, the output is 8. So this is 8. Okay. Now I'll stop the video and try to calculate g of f of 3 and see if you understand. Okay, so let's erase all this. G of f of 3, this is g of, what's f of 3? When x is 3, f of 3 is 3. And then when the input is 3 for g, the output is 2. So g of f of 3 is 2. As you can see, they're not equal, and that makes sense because composition does not commute. So f of g is not the same as g of f. Maybe let's try another one. They don't ask us to do it, but I'm going to ask you to do it. Try to calculate f of 4. So it's possible to compose f with itself. So here we'd be sending 4 into f. What comes out of it is f of 4. And then we send f of 4, the value of f of 4, into f again. And then what comes out is f of 4. Like that. Okay. So pause the video and do it. Okay, so f of 4, let's erase this. When the input is 4, the output is for f 1. So f of 4 is 1. Now we have to figure out what's the output when the input is 1 now. When you send 1 into f, what comes out is 6. Now in the next example, we're going to use a graph to calculate f of g of 1. So we're given the graph of g and the graph of f, and then we want to know what's f of g of 1. Okay. So same idea. Maybe try to do it by yourself if you can. Pause the video and come back. Okay, so we need to calculate g of 1 first, right? So it's 1 that goes into function g, and then what comes out is going to be g of 1, and then you're going to put that into f, and what's going to come out is f of g of 1. Okay, so let's do this. So g of 1, so we need to see, okay, when the input is 1, the output g of 1 is, well, it looks like it's 2.5 or 5/2. Okay, and now we want to figure out what's the output of f when the input is 2.5. So I need to get here and look at the output. So it seems to be 5.5. Okay. So I'm going to ask you to do another one. We're going to do f of g of 3. That's what I'd like you to do. F of g of 3. Try to do that one. Okay, so f of g of 3. So g of 3, when x is 3, g of 3 is minus 1. When x is minus 1, actually that doesn't work. We'd have to okay. Let's do I'm sorry about that. We'd have to know, right? F of minus 1, we'd have to know what f of minus 1 is. We can have more, maybe we can actually do it. Maybe we can extrapolate. It looks like it would be so this is minus 5, minus 6, roughly minus 7. Okay, of course we don't know for sure, right? All these numbers are approximate, so it'd be something like that. But at least this example, this last one where I messed up a bit, like asking you something that's not necessarily available from our graph, it shows you that sometimes we don't have all the information to recover the entire composite function. Okay, so hopefully when they're asking you something, you have the information given to you, especially with the table. You only have a selection of function values for given x values, and you need the specific ones in order to calculate the composition of two functions at a point.